All, welcome to the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at procedures and their role in assembly language. So what is a procedure? Very simply put, it's actually a set of operations which logically belong together. Now the best part is procedures can be called from different places in the code. Let me give you a simple example. Let's say you would like to add two numbers and you want to create a procedure for that. So you go ahead, define the procedure, call it add numbers, and then whenever you would like to add two numbers in your code, you can call that procedure. In NASM, calling procedures is very simple. We basically use the call instruction followed by the procedure name, which in the case of NASM is just the label. So here is a simple format. We first define the procedure name. After that, we write out all the instructions inside the procedure. And once we are done with the procedure, we use the instruction ret, which signifies that we would like to return from the procedure and continue executing from the next instruction. So let me show you how this looks like. Let me open up procedure.nasm. And this is really procedurizing the Hello World program, right? So here is how it works. If you notice, most of the format is exactly the same. We define _start as really the entry point of the program. But above that, if you notice, I have defined a label called Hello World proc, or really Hello World procedure, and inside which I have my syscall, which prints Hello World on the screen. And after this, I have the ret statement, which signifies return from procedure. Now, if you notice what I'm doing in here, at the beginning of the program or at the entry point, is I'm moving the hex value 10 inside RCX. And after that, I'm running a loop in which I first save RCX, then call the Hello World procedure, and then pop RCX back again, and go ahead and run this loop till the time RCX does not become 0. And after that, I just do my graceful exiting using the syscall. Right? The data section pretty much remains the same. We've defined Hello World and the length. So as you can clearly see, we can now go ahead and call this procedure from anywhere in the code. And this gives us a ton of flexibility of reuse of code. So let me go ahead first, assemble and link this program. Then create the binary. Let me run the binary. And as you can clearly see, it's printed Hello World multiple times based on the value of RCX. Fantastic. Now let's look at how this works from within GDB. So let me create a break for the starting point. Set disassembly intel. Run the program. Lay out the assembly. Lay out the registers. And now let me run through the program. So we move this into RCX. Now we push the value of RCX on the stack, and you would actually notice something very, very interesting. We are about to call the procedure. Now, if you remember, I said when we hit ret, we go back to the very next instruction, which in this case would actually have to be 0x400EB. Right, that's the location of the next instruction. Now the call statement pushes this address onto the stack which is where it remains stored till the time we actually recover it with the ret instruction. Now let me show you what I mean. Let me actually dump the top of the stack. Right, currently it has the value hex 10 in it, just as one would expect, because we pushed RCX. Now let me actually do a step I. And if you notice, we are inside the hello world procedure. But if I now dump the top of the stack, actually dump two values, what you would actually notice is that the first value is really the address of the next instruction just following the call instruction, right? And this is something we've already looked at. You can clearly see that the address pushed in is just after the call. We have this instruction pop RCX located at address 4000 EB, and really this is what gets pushed on the stack. Now as we proceed through the procedure, nothing much happens really. Now after we've gone ahead and printed hello world on the screen, we are about to hit the ret statement, which returns from the procedure back to the very next instruction. Now let me look at what is there on the top of the stack once again. And as one would expect, we would have the address of the next instruction, which is really the pop RCX instruction. So you can see clearly, here is this address. Now, as soon as ret is executed, this value is going to be put inside RIP and execution would begin at this point. So let me also dump the value of RIP. This is what it is currently. And here is what now we are going to do is execute this, right? So let's do a quick step I. And if you notice, we are currently in here, next instruction, and of course that would be reflected in the value of RIP. Right, if you notice, RIP is currently pointing in here, which is pop RCX. And now if you look at the top of the stack, you would pretty much find the value 10 in there, which we are just about to pop using the pop RCX instruction. Fantastic. So this is really the most important thing you need to remember when dealing with procedures, which is the call instruction pushes the address of the next instruction following call on the stack, and when we hit the ret instruction inside the procedure, that goes ahead and pops that return value back inside the EIP or rather RIP register. Right? Now this will come in really very handy when we look at shell coding and all of that. So it's an important concept. That's all I had in mind for this video. In the next video, what we are going to do is look at other interesting things. Now, of course, one of the points which I'd like to add is arguments to procedures can be passed via registers, stack, sometimes even the memory location where there could be larger data structures. Just depends what you want to do. So that's all for this video. If you're enjoying your time at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.